Okay, on Friday we were going over displacement versus time graphs, and you have all these notes if you were in class on Friday because they were from the PowerPoint. Okay, so we talked about the fact that the slope of a displacement versus time graph is simply the velocity. So you can pick 2 points of the line on that graph and find the slope of it, and that's the velocity over that segment. Then we spent a fair bit of time saying what is the slope on each of these different graphs look like, and therefore what does the velocity look like, and what is the object doing. So I think we went through all of the graphs on the front side of the page, and we went through the top 3 on the back side, and I think we were on H just as we ran out of time. And I think we were talking about what is this object doing, and right as the bell was going, a student was saying, so it's initially moving in the negative direction. Okay, so it's moving in the negative direction. When it gets to here, it turns around and it now begins to move in the positive direction. It's slowing down here, its slope is getting less, it's speeding up here. So slowing down in the negative direction, speeding up in the positive direction makes its acceleration positive the whole way. Okay, and I think most of you have your sheet, so feel free to pause this video and fill that in there. And then the next one is just the opposite. So here, it's slowing down in the positive direction and speeding up in the negative direction. Okay, so it's slowing down, maybe going east, it stops, speeds up going west. Slowing down, maybe going up, stops, speeds up coming down. So it's initially moving in a positive direction, slows down, stops, turns around, speeds up in the negative direction until it gets back to where it started. So slowing down positive, acceleration is negative. Speeding up in the negative direction, its acceleration is still negative. Best example of this one is throwing a marker up in the air. As it goes up, it slows down, it slows down, it slows down, it stops, it turns around, and it speeds up on its way back. Okay, so again, on your notes, you might want to pause this and fill in your notes there. Okay, the pieces that we didn't get to. How does one find the distance traveled? You just read it off the side of the graph. So if we go back to this graph on your sheet, and I said to you, how far did it travel in like 3 seconds or 2.5 seconds? You just go up, hit the dot, go over and say, oh, 5 meters. So you just read it off the side of the graph. Okay? How do you find the displacement? Again, you read it off the side of the graph, but you have to keep the directions. So it would be 5 meters east if it had gone down, like some of these. And if it was down here, then you would have to say west or south, depending on the direction. Average velocity is still displacement over time. Average speed is still distance over time. Okay, so those are the 2 equations we've been using all along. And then this question, how do you find the average velocity in the first 6 seconds? I had a graph on the PowerPoint that we would have done it, but we don't have the graph right here. So I asked you to do the front side of this sheet for homework, the displacement versus time side. So let's take a look at it. It says, was the object ever stopped? Stopped means its velocity is 0. If its velocity is 0, means its slope is 0. So it stopped here in this spot, it stopped here, and it stopped here. So what would you write in your blank? You would write, yes, from 3 to 5 seconds, from 10 to 11 seconds, and from 19 to 21 seconds. Okay, so that's when it stopped. What is the total distance traveled in 8 seconds? So you go to the 8 seconds, total distance traveled. So it went up, it went east for 6 meters, it stopped, and then it went south for 6 meters. So total distance traveled, 12 meters. What's its total displacement? Well, it's back where it started. So its total displacement is 0 meters. What's its speed at the 2-second point? Whenever it asks you to find the speed or the velocity at a time, it's really saying find the slope. So to find the slope at the 2-second point, you need to pick 2 points. Why is it doing this? There we go. You need to pick 2 points. So I'd probably pick the 2 endpoints. I would pick this one and this one. And I would do the slope. Okay? And so the endpoints here are 3 seconds and 6 meters. And down here, of course, there's 0, 0. So to do the slope or the speed is equal to change in y over change in x. So change in y would be 6 meters minus 0 meters over 3 seconds minus 0 seconds. So 2 meters per second. It's speed, you don't need a direction. But if we skip down to number 6, velocity at the 2-second point, it would be exactly the same numbers, but this time you need a direction. And so it would be 2 meters per second east instead of just 2 meters per second. All right, going back to number 5, what is the speed at the 6-second point? So 6 seconds is here, and it's not perfectly on a point, so pick the endpoints. Because remember, the slope of the line is constant, and that means the speed is constant. So at 5 seconds and 6 meters is the first point, and at 8 seconds and 0 meters is the second point. And so when you do the slope, again, change in y over change in x, if we go 0 meters minus 6 meters, and if we start with the 0, we have to start with the 8 seconds minus 5 seconds. Negative 6 on the top, positive 3 on the bottom. We get a negative 2 meters per second. But the negative is just trying to indicate direction, and since this is speed, we don't actually need to say anything about the direction. So you could just put 2 meters per second. But down here, number 7, when it asks for the velocity at the 6-second point, that 2 meters per second, the negative now becomes important. You don't leave the negative on it, though. You rewrite it as 2 meters per second, and it would be west. And I know it's west because the top tells me it's an east-west graph. Okay, next question, velocity at 13 seconds. So again, you need to find the slope. So whenever it asks you for speed or velocity at a particular time, find the slope. I'm not sure if that actually goes right through there. Yeah, I'm going to guess it does. So 1 point is that's a 15 seconds and 0 meters, and the other point 11 seconds and negative 8 meters. Okay, and so we do the slope again. So m is equal again to change in y over change in x. So if we start with our 0 meters minus 8 meters, and then that'll be over 15 seconds minus 11 seconds. So we get positive 8 on the top, we get positive 4 on the bottom, and so it's positive 2 meters per second. It's asking for a velocity. Positive means east. When did it return to its starting point? Anytime it gets back to the x-axis, it's returned to its starting point. So at 8 seconds, at 15 seconds, and all the way over here at 26 seconds. Okay, so 8 seconds, what do we say? 15 seconds and 26 seconds. What was the average speed in the first 8 seconds? So average speed, we just said on that other screen, average speed is equal to distance over time. So what was its distance in the first 8 seconds? Well, we found it up top here. We found it in number 2. It was 12 meters. So the average speed will be 12 meters over 8 seconds, which is 1.5 meters per second. What is its average velocity? Average velocity